Okay. Event handling is tricky, and it was even more tricky before the advent of lambdas. Because Java is object-oriented, you need to create a bunch of objects, and those objects are responsible for doing the listening. So, sort of the big difference between the code you've been writing versus event-driven code is that when you have a main starts, it opens up, and it does its tasks through the order of whatever is inside of the main method. In event-driven code, you run the main, and the purpose of main is to create your interface and lay everything out. And then you're not quite sure what the user's going to click on. And that, that might start a process that needs to begin but will finish later while the user can still do more work. Otherwise, the program is left hanging while the code finishes doing its task and the user can't progress. So, with that in mind, as we work through event handling, events are fired off by interactions with the components. It could be entering text into a text box. It could be pressing a button. It could be dragging a slider. It could be clicking on an image. All of these things fire off events, and then we can choose to either ignore them because they're not supposed to be interactive, or we need to handle the event. Now, there are different types of events depending on what kind of component we're working with. Frames have window events and menus have action events. In either case, we need to add a listener to these events so that we know how to respond to them. One way to handle events is to have one massive method with a bunch of switch statements or if-elses, where this one object listens for all events and then dispatches them to the appropriate object. So this object would implement the action listener interface, and remember from last class, an interface is a contract. We must have these methods with these parameter types and these return types. So in order to do our graphical user interface, we have to implement the action listener code interface. The action listener interface specifies that the name of the method is action performed. Then it needs to register itself with the object that performs the action through the add action listener method. And the thing is, the object that has the action listener interface is responsible to work out which component has requested the event. It doesn't scale very well. If you have anything more than the simplest of interfaces, this quickly becomes unwieldy. So what does it look like? The interface action listener has a public void method called action performed, which will take the action event. And so, for instance, our image viewer implements action listener, public void action performed, action event. We traditionally named events E. And then, because this is the centralized model, ask that action event to get the command. If the command was open, then we do something for open. Else, if the command was quit, do something for quit. This sort of centralized model is going to be, even for a reasonably moderate application, will become many, many, many lines. And it is not the common pattern for actually doing event listening. It works. You'll see it. You should be aware of it. But as soon as you have many, many menus, this is going to break down. And also, tying things together through text strings is inherently fragile. If there is a typo in either the code or in the interface, the event can't get fired. So that creates a problem. So the more commonly used method is frankly a little funky. Now, here's the nice thing. Lambdas make this task easier, which is when we create the object, we attach a listener to it at that time. And the thing is, most event handlers are designed to fire off a single method. When you click this, do this, and then that method can handle that. Which means that the Lambda syntax, which is very different from normal Java, works fairly well here. If we use lambdas, we do something like this. Create our menu item. Okay, so we have a menu item called open item. The display string is open. Then open item dot add action listener, and this is the action listener. And this piece here is our lambda. We have an action event called EV, and the result of that event is to call the method openFile. It is very, very elegant to use lambdas in this way. Just going to jump back for a bit to what we had before in comparison. Get the event, ask the event to get the action command, then if the command equals open, do this thing, else if. So with the centralized listener, everything is tied to this one item, one object, and the decision is made. With lambdas, when we create the item, we just attach the listener and say, this is what we need to do when that happens. Now, if this is this simple, why did the other option ever come into play? And I need you to remember that lambdas are a relatively recent occurrence in the Java world. So prior to the creation of lambdas, we would need to do this with Java objects. Okay, so we would need to do this with Java objects, but also these Java objects would be very specific to the object that they were being attached to, which leads us to some funkiness in Java that you may not have known that you were using at one point, but that and you might not have known that this is an option to create Java, which is you can put a class inside of a class. Now, scope rules still apply. So if we have one of these inner classes that's defined inside of this outer class called enclosing, it only exists inside of enclosing. The idea here being, you might, in order to break the task down, it might be necessary to have objects in your project, but that object is literally only needed in support of this other larger object. Then having an inner class meets that need. So if there is an inner class, it's localized within the enclosing class. And because it's part of the class, inner classes are part of the class and have access to the private members of the enclosing class. So you don't even need to use accessors or mutators. You don't have to change it to be protected. So it's another way to nest information in your solution. So Java supports this syntax, and this is what we would do before lambdas. And we would actually do this creating what's called an anonymous inner class. So you'll recall from anonymous variables, we just kind of created the variable when we needed it, and that was in reference to like putting things into a collection, like in an array list. We can also just create the class when we need it. So it obeys the rules of the inner class, and you create one-off objects where even naming the class isn't necessary. Now, the thing is, the syntax is kind of funky, and we reference that class through its supertype because it doesn't even have a subtype because we didn't give it a name. So this is how it would be applied with interfaces, and you can kind of see why Lambda has become a dominant way to do it instead. You see, prior to Lambdas, we would need to set up our action listeners this way. Okay, so same situation that we had before. JMenu, open item. So this is going to be the response to open. Add an action listener. What are we adding? So this parenthesis here is closed by this parenthesis down here. Make a new action listener object, and the definition of the action listener is to have a public void action performed method which takes that action event and returns and calls open file. Wait, what? When you compare that to the Lambda version is just like, oh, the event, we're going to call open file. So this was necessary because of all of the other rules of Java. Let's break it down maybe just a little bit more. If we restructure it, the parameter to action listener requires an action listener object. So we're going to make a new action listener object. Well, and remember, action listener is an interface. So it's not just something we can create, we also have to define. So the new operator creates the object. Action listener is going to be our object of the type, which is the interface. It's an anonymous. So new action listener, there's nothing inside the parentheses. Okay, so that's anonymous, but we're going to create the action listener anyway. And remember, action listener as an interface requires us to implement action performed. So the object creation is this class definition here, and this whole thing is the parameter that's being passed to the add action listener. It works. It's the way it was done until lambdas were brought into Java, or you use that centralized method dispatch, but it's clunky, and you have to either accept it or understand a lot about Java to know why it works. And so it gets in the way of, introducing GUIs early on in your process of learning the language. So with that kind of structure, maybe exiting on window close, for instance. So you'll recall when I clicked the close the window, it didn't actually end the process. We could do something like this with that same kind of anonymous class behavior. Add a window listener. We're going to make a new window adapter. And the window adapter object, we're going to define that the window closing event results in calling system.exit0, which closes things down. Now, this is a hard close. Okay, we click the button, boom, everything's dead. Ordinarily, we do things like, are there any open files? Should we prompt the user to see if they want to save? All of this other stuff. But the key thing is, this is the exact model of what we were looking at here. Okay. So, lambdas, different syntax, make our life a little bit easier. Let's put a bow on some of this, and then we'll go and look at some of the internals of making a GUI. As we're designing our GUI, we want to keep the application structures cohesive. Okay, and remember that's a term now that has meaning. Okay, we don't want the GUI to be part of the task that does the actual work. We want to separate some. We want to separate those. They are going to be coupled by definition. They're coupled. Okay, but we don't want to have the thing that's responsible for doing the display to also be the thing that's responsible for doing the work. We can rely on the fact that there are predefined components, and we will come back to the idea of layout managers, and you're going to be wrestling with those for a little bit. Many components can respond to user interactions, and we can capture those events. And those events don't have to just be a click. It could be a right click, a left click. We could write some code to check for a double click or a scroll wheel motion, or if the mouse button is still pressed, if we want to implement a click and drag. So there's a lot that can be done. And if the component is meant to be interacted with, if it is a reactive component, it will hand those events back to listeners. And details about that event will occur in that variable E. When we can, we're going to use that lambda syntax to implement the listeners. It's just so much simpler. But with things like window events where lambdas aren't allowed, we have to still know how to use those anonymous inner classes because they're used where lambdas are not possible. You may wish to go back to Chapter 5 and review what the lambda syntax is. But for our purposes, because we're not going to focus on going with lambdas beyond this, you can also just accept it as a pattern and tuck it away as a future portion of the language that you're going to want to learn more about when there's time to apply it to other problems. But for right now, the basic syntax from that slide and from our sample code will be useful for generating your GUIs moving forward.